Welcome and welcome back to 3 Inquisitive Kids. This video is all about central symmetry. Here's our course outline for this chapter. Again, this is our second to last lesson of this entire chapter. Our learning goals for today is to understand and master the definition and properties of central symmetry, and be able to identify central symmetric figures, and be able to use central symmetry to solve problems. What is the center of rotation in the rotation from A to B? How many degrees is the rotation angle? It's asking you, how much is this angle, the angle it rotated by? Well, now the rotation angle, as you can see, it's 90 degrees. So then we can answer the previous question. Angle AOB is half of angle AOC, which means that angle AOB must be 45 degrees. What about from A to D? Now it's 180 degrees. Magic cards. There are 4 cards. After rotating 180 degrees, one of the cards look exactly the same. Can you guess which card it is? It might seem like all these cards look exactly the same, except that 4 is the correct answer. Because you can see that at first, for example the 7, these 5 hearts are pointing downwards, but then when you flip it, only 2 hearts are pointing downwards. And for this 5, it's the same thing. Because their images, the spades and the hearts, for example, they are not what we call central symmetric. Yet this rhombus is central symmetric, because when you rotate it by 180 degrees, it looks exactly the same. Observe the following transformations and find what they have in common. We can see that the rotation angle was both 180 degrees, and the transformed figures overlap with the original figures. If a figure, such as triangle ABO in the previous slide, is rotated 180 degrees about point O and overlaps with itself, then triangle ABO and triangle CDO are central symmetric about point O. That's how you would say it in math. Point O is the center of symmetry for them. As shown in the figure, triangle OCD and triangle OAB are symmetric about point O. Point O in this case would be the center of symmetry. Point A and point C are corresponding or symmetric points. Point B and point D are also corresponding or symmetric points. So central symmetry is a special type of rotation, and the rotation angle must be 180 degrees. And central symmetry is about a special relationship between the position of 2 figures. Rotate set square triangle ABC about point O and draw a triangle A prime, B prime, C prime. If you don't know what a set square is one of those rulers that's shaped like this that you may find in your toolbox. So after rotation, we are left with triangle A prime, B prime, C prime. Triangle A prime, B prime, C prime, and triangle ABC are central symmetric about point O. What relationships can you find from the figure? So what were the equalities that you can see? You can see that OA equals OA prime, OB equals OB prime, and OC equals OC prime. And triangle ABC is congruent to triangle A prime, B prime, C prime. In 2 central symmetric figures, a line segment connected by corresponding points passes through the center of symmetry and is bisected by the other line segment. And central symmetric figures are congruent. We are given quadrilateral ABCD and point O. Rotate ABCD about point O and draw A prime, B prime, C prime, D prime. In order to draw a figure central symmetric to ABCD about point O, you only need to rotate 4 points, A, B, C, and D about point O, and then connect the dots. It's the same thing as any other transformation we've learned before. So we first connect AO and extend it to point A prime, so that OA prime is equal to OA. And so we have A prime as our corresponding point. Plot the corresponding points of B, C, and D with the same method. So now we can see we have our points A prime, B prime, C prime, D prime. Now we connect them to result in quadrilateral A prime, B prime, C prime, D prime. Given triangle ABC and triangle A prime, B prime, C prime are central symmetric, find the center of symmetry, which is O. So in our previous problem, we were trying to find the rotated figure. Now we're going to be going in reverse. How can you find the center of symmetry? You can see that B and B prime are corresponding points. So we connect B and B prime and use a ruler to find the midpoint of B prime, which is O. And O is that center of symmetry. Here's method 2. B prime, and C prime are the two sets of corresponding points. So we connect them, and since two different lines must intersect at a point, we have to find the intersection of C prime and B prime to get point O. So if you don't have a ruler, you can use method 2. Given triangle AOB and triangle DOC are central symmetric, the area of triangle AOB is 12. AB equals 3. Then the height on side CD is blank. They're asking you, what is the height on side CD? So you have to use central symmetry to help you. So the height is 8. Compare and contrast. In axial symmetry, we learned before, we have a line as the axis of symmetry. In central symmetry, however, the point is the center of symmetry. And in axial symmetry, we fold along the axis of symmetry. You can almost think of it as like 3D. But in central symmetry, we rotate it about a center by 180 degrees. And in axial symmetry, the figures overlap after reflection. In central symmetry, it overlaps after rotation. What can you find from comparing the following rotations about point O? Here is the line segment, and here is the parallelogram. Well, they both rotated 180 degrees about the center, which is point O, and the rotated figures completely overlap the original figure. If a figure is rotated about a certain point by 180 degrees and overlaps with itself after the rotation, then the figure is central symmetric, and the point is the center of symmetry. Which of the following figures are central symmetric? This first one is, second one is, the third one, when you rotate it, it still is. The fourth one is not. Diagonals AC and BD of rectangle ABCD intersect at point O, and the lines through point O each intersect AD and BC at points E and F. AB equals 2, BC equals 3. Then the area of the shaded part in the figure is blank. So this solution explains it very clearly. All you had to do was, for example, move the shaded area all into 1/2 of the rectangle to get 3. Use a ruler without any marks and draw a straight line that splits the figure in half. How would you do this? Remember, you have to use a little bit of thinking and what we learned about central symmetry. Here's method 1. You first have to split this figure into 2 rectangles. You find the center of this first rectangle and find the center of the second rectangle. Then you connect the dots to get 2 equal parts. Here's method 2. In this case, you split this entire figure into 2 rectangles this way. Then connect the dots to get method 2. The key is to find the center of symmetry of both rectangles, and then draw a line through the points. Instead of trying to break this original figure in half, you have to extend these 2 sides to make a full rectangle. And then you find the center of symmetry of this big rectangle and the center of symmetry of this smaller rectangle. Then you connect the dots. It's another way to split the figure in half. Again, this is our magic cards from the very first slide. So these are the differences. Only this card remained the same. Central symmetry. Today we learn about the center of symmetry and central symmetric figures. We learned that in central symmetry, the rotation angle is 180 degrees, and the line created by connecting corresponding points passes through the center of symmetry and is bisected by the center of symmetry. Method 1 is to make centrosymmetric graphics, and method 2 is to find the center of symmetry. Those were the two types of problems we did. And in centrosymmetric figures, you have to rotate the figure by 180 degrees about a point and overlap with itself. And a line that passes through the center of symmetry divides a figure into two equal parts. I hope you learned something from this lesson, and be sure to come back for our next lesson of this chapter.